Hello and welcome. I am Rajiv Gupta, a certified trainer and a senior technician at PCMacPlus.com. This is the Introduction to A Plus Certification 2009 training review that I have put together for my students and individuals in the community. Today I am going to review the Part 2 of the Domain 1 Hardware Section 1.1 Floppy disk drive, hard disk drive, solid state versus magnetic, optical, and removable drives. Let's get started. Optical storage is a storage method in which data is written and read from a laser for archival or backup purposes. Typically, data is written to optical. For several years, proponents have spoken of optical storage as a near-future replacement for both hard drives in personal computers and tape backup in mass storage. Optical media is more durable than tape and less vulnerable to environmental conditions. On the other hand, it tends to be slower than typical hard drive speeds and to offer lower storage capacities. According to Optical Storage Technology Association, current optical speeds are approaching those of hard drives. A number of new optical formats such as Blu-ray and ultra-density optical that use a blue laser to dramatically increase capacities. How does it work? A typical CD-R has a storage capacity of 74 minutes of audio or 650 megabytes of data. Used with a CD burner or recorder, users can easily store music and data files with the ease of popular CD recording software such as Roxio Easy CD Creator or Nero. Windows XP also has its own built-in tool which users can burn CDs using the drag and drop method. The recording begins with the laser indenting small pits or tiny indentations on the die surface of the disk. The heat of the laser burns each pit through a chemical reaction, causing it to become opaque. This pit will then reflect less light than the areas that are not heated by the laser. This irreversible process starts from the innermost region of the disk to the outermost region. When the laser reads the disk, it scans the refractive dye along the groove and reads the change of reflectivity, which decodes into electrical signals, which is subsequently encoded into binary bits to be processed by the computer. We don't all have industrial CD presses in our homes, but that doesn't mean we cannot make our own CDs. On the top side of the disk, you have the protective acrylic layer that prevents scratches to the recording material. Then you have the actual recording layer, the dye layer, where the recording laser burns data bits and lands into the polymer dye. The laser burns non-translucent data bits, translucent data bits, which absorbs light that would be normally reflect back the read laser. The parts that are not burnt are the pits. The reflective layer is the layer which reflects the red read laser beam back to the optical sensor, which translates the pulses into ones and zeros. There is one drawback to CD-R technology. It's only recordable once and is permanent. You cannot record over existing data. That is where CD-RW, which is CD rewritable, comes to the rescue. CD-RW uses a technology called phase change, which creates pits and grooves by changing certain portions of the recorded layer from reflecting to absorbing light. DVD, short for digital versatile disc or digital video disc, depending on which side of the industry you are on. DVDs are designed to supplement and eventually replace the CD. What is the difference? A DVD and a CD both look the same, almost the same. Well, physically in the size they are the same, but microscopically they are not. The pits and lands on a DVD disc are much smaller than those on a CD, and they are also more closely packed. More information can be packed on the DVD because the size of each bit is physically smaller than a CD. Because of this, the read laser also needs to be smaller. A read laser that reads CDs is red. Red has a longer and larger wavelength, thus making the beam larger. DVDs need something more precise to be read. A blue laser is used for DVDs because the blue light wavelength is much shorter and thinner, thus giving the precise beam. Double-layer DVDs, recordable discs, offer up to 4 hours of high MPEG-2 video or up to 8.5 GB of data, which is gigabyte of data on a single-sided disc with 2 individual recordable layers. Double-layer capable recorders will have the ability to record on the new double-layer DVD recordable disc as well as traditional single-layer DVD disc and CDs. Blu-ray, also known as Blu-ray BD, which is Blu-ray disc, is the name of the next generation optical disc format jointly developed by the Blu-ray Disc Association, which is BDA, a group of the world's leading consumer electronics, personal computer, and media manufacturers including Apple, Dell, Hitachi, HP, JVC, LG, Mitsubishi, Panasonic, Pioneer, Philips, Samsung, Sharp, Sony, TDK, and Thorison. The format was developed to enable recording, writing, and playback of high-definition video, as well as storing large amounts of data. Here, this slide is actually showing you how much data can be held by a single-layer DVD versus a dual-layer DVD. Some are single-sided DVDs and some are double-sided DVDs. I request that you memorize these numbers. Here we are breaking down and showing you what each of the acronyms stand for. CD-ROM is CD read-only memory. It can read CDs. CD-R, CD recordable. That means it can record or write to a CD-R, and it's also called write once CD. CD-RW is CD rewritable. Then we have another table for DVDs. We have DVD-ROM, DVD-R, DVD-R double layer, DVD-RW, DVD-RW double layer, DVD plus R, DVD plus R double layer, DVD plus rewritable, DVD minus RAM. So I would also memorize this table for your exam. This table is about Blu-ray. So you have Blu-ray disc minus ROM, Blu-ray disc minus R, Blu-ray disc minus RE, which is rewritable. Please record these in your notes and memorize these acronyms. They could be in your exam. We have two technologies that we need to know when we are talking about labeling the CDs or the DVDs. It's called light scribe technology versus label flash technology. LightScribe technology was introduced to the market by Hewlett-Packard in 2004. At that time, there was no other technology available that would let you laser etch a design to the label side of an optical disc. Another program called Disk T-AT2 had been developed and released by Yamaha in 2002, but unlike LightScribe technology, Disk T-AT2 only allowed people to burn a design to the unused part of the data side of the disk. Disk T-AT2 was scraped in 2003, but later developed further into what is known as label flash technology, which was released in December of 2005. In contrast to its predecessor, label flash technology allows you to burn images and text to both the label and the data sides of a disk. Both technologies offer the world something that is both innovative and fascinating and has helped to solve some of the problems that computers users face every time they burn multi-disk. What is LightScribe? When LightScribe first came to the market in 2004, there was a three-word phrase strongly associated with the technology: burn, flip, burn. The idea was that a person could burn both data and label portion of disk with one drive, simply flipping the disk over in the process. The introduction of the technology offered people an alternative to both the smear-prone labels printed over an inkjet direct-to-disk printers and adhesive labels that can cause problems when used with high-speed or slot-loaded optical disk. Labeling with LightScribe technology required a so-called LightScribe enabled disk drive and special optical disks that have a dye coating on the label side. In the beginning, LightScribe disk media was available only in sepia color and in CD-R and DVD-R formats. What is Label Flash? Label Flash was introduced to consumers in December of 2005. This project, initiated by Yamaha and Fujifilms, implements technology originally released by Yamaha in 2002. Labeling a disk using Label Flash technology can only be done with a special Label Flash compatible disk drive and disks that have a special dye similar to that of LightScribe media. The disks are blue in color and are only available in DVD format. CD-ROM, DVD-ROM, and other disk drive cleaning. Why? A dirty CD-ROM or other disk drive can cause read errors where reading disk. These read errors could cause software installation issues or issues while running the program. What is the procedure? To clean the CD-ROM drive, we recommend purchasing a CD-ROM cleaner from your local retailer, such as local Radio Shack. Using a CD-ROM cleaner should sufficiently clean the CD-ROM laser from dust, dirt, and hair. In addition to cleaning the drive with a special disc designed to clean drives, make sure, however, that the tray has been cleaned. This completes the part 2 of Domain 1.1. Thank you for watching A+ Certification 2009 review at PC Mac Plus. Please recommend PC Mac Plus on YouTube to your colleagues and friends.